So now I will put on my NVM Express hat. People wanted to get me a hat that had both, like SAS on one side and NVM Express on the other, or a shirt that, you know, one on the back and then. This is slightly different, you know, slightly different content. This is a little bit more kind of specification oriented. So whoever made this, the person to help me make the slides, all right, that's just me. So okay, from an agenda standpoint, this will be a very quick overview of NVM Express Technology. Again, I think it may be one slide. Then we'll look at the market, a couple of slides on the market. Then just, it says overview of NVMe specification updates. Basically, it's, you know, where you'll get an idea where the technology is going based on the specifications that are being developed. And then just a quick look at some of the use cases for NVM Express Technology. Kind of a similar format to this SCSI Trade Association one. NVM Express has over 110 members, and then there is what's called a promoter group. So you think of that as the board of directors. Half of the board gets put up to vote. The terms are for 2 years, and they alternate. Like 10 will go in this year, 10 will get reelected next year, and then 10 will get reelected. So but you can get reelected. But this allows opportunities for companies to, you know, come in and out, you know, as the elections happen. So here are some of the areas of focus for NVM Express Technology, SSD controllers and some of the applications. SSD controllers, storage, of course, SSDs, NVM Express over fabrics and there's other protocols, other transports that are supported. But in a similar, let's have the quiz time again. What was NVMe technology originally developed as? I think Chris touched on this a little bit. An SSD interface? Yeah. Who thinks it's E? For those Monty Python fans. It's an SSD interface, command set and transport. B, a physical transport. C, a command set. D, non-volatile memory, or a bit for Monty Python's Flying Circus.
Yes, indeed, but C.
So you think? You think?
I think D.
All right. Yeah, there's only one right answer for this. All right. So who thinks it's A?
Show of hands. What did it say?
You think it's A? Okay. B? We had another A over there. Any takers on B?
Yeah.
Okay, there's one. All right, there's always got to be one, right? C, command set.
Everything.
Well, there's only one right answer, so you can only pick one.
Is there only one answer?
Yeah,
It's D, non-volatile memory. And obviously it's not E. A shrubbery. And now for something completely different. So, you know, this is the operative word. It was developed as something, not for something. So the answer is command set. And I thought Chris kind of outed this question during we were talking about SAS, and he said that SAS is a command set and a physical transport, where NVMe is not. So the answer is C. It is a command set. So the specification, basically, it was released in 2011, and it was really designed for SSDs, and it was designed to be fast, simple, and high performance. The original use case was client SSDs, and then of course it evolved into more stringent features and capabilities for data center use. But now it has certainly grown into much more than the original intent. And of course, NVM Express sits on top of the PCI Express physical transport. Since SAS can't be the only one with a storage chart, NVM Express, here's one that highlights NVM Express. The way this is oriented, PCIe NVMe should have been on top because that is the biggest chart. So this is specific to enterprise SSDs, which includes hyperscale. So basically anything used in the data center, but this is specific to SSDs. And it's very clear that PCIe is the vast majority, and the combined capacity of SATA and SAS and anything else proprietary is getting smaller. So it's pretty clear that from an SSD perspective, NVMe is the command set. So just a quick look at what the specifications look like. So originally, it was one specification that was about 70 pages, and since then, it has a base specification that you have to basically implement this. Then you can kind of pick and choose which commands. There's transport specifications. These are basically running NVMe over PCIe, RDMA, or TCP. So you can see this can run across other transports. And then there's MI, and then the boot spec, kind of other specifications. So the NVM command set plus the base specification is what you would think of if you're deploying an NVMe SSD. There's another command set spec for zone namespaces, key value command, and then subsystem local memory plus computational programs combined is what most people refer to as computational storage. So you can see how it is really kind of proliferated. Again, it initially started out for client SSDs, but basically all of this is for data center use. And there really isn't a whole lot being developed specifically for client SSDs anymore, since the scope of a client SSD use is pretty limited.
Do those command sets overlap?
For client?
Well, you've got all of those command sets. Do they contain some of the same commands?
Well, like these?
Yes. Yeah.
Well, I think anything that's common would be in the base specification.
Yeah.
Then these are going to be specific to those types of deployments.
Yeah.
So the green ones are new in 2024. The other ones get updated with ECNs and things like that.
I don't understand the boot specification.
I think this allows you to boot over a network and other kind of unique scenarios, as opposed to just, I think a hard drive or an SSD, booting from inside of a server is pretty standard. But this is more looking at kind of unique use cases, like over a network, perhaps over these various transports. Okay, given that, there's some activity going on. How busy was NVM Express in 2024? As of August 2024, so what's happened in between January 1st and August 2024? One base specification released, 70 plus technical proposals, 80 plus ratified technical proposals, ratified ECNs, E, all of the above, or F, none of the above. Yeah, it's meant. This one was meant to be a little bit tricky, but who thinks it's A? There's only one answer here. Anybody think it's B? There's one B. Anybody think it's C? Anybody think it's D? Anybody think it's E? Anybody think it's F?
F would be really mean.
Yeah, we didn't do anything. Well, this could have been like, 21 plus or something.
I think it's a small shrub.
So the answer is D, all of the above. So the 2.1 base specification was released, plus 71 authorized new technical proposals, ratified 82. So they did more than 71 because some of the proposals were proposed previous year. And ECNs, which were used, are changes to existing specifications to make updates. So 22 ECNs were ratified. And of course, we got to tie in artificial intelligence in some way. But I think everybody pretty much knows that NVMe SSDs are what are being used in pretty much any SSD environment these days. So this is a look at some of the recent features and enhancements. And this is just kind of the category. Fabrics enhancements, this is like over TCP or RDMA or over PCIe. Emerging technologies, these are kind of new features like computational storage, flexible data placement, NVM subsystem local memory. Again, that is part of computational storage. Security enhancements. So key per IO, that's one of the things that was also in the SAS presentation I showed just a few minutes ago. So that's an example of features that will that'll be adopted by the other group. Data and virtual machine migration. Live migration was announced last year. Cross namespace copy. And then there's always going to be management features that get implemented, even if they're small, kind of just things to make them a little bit more manageable. Is it getting chilly in here for some folks? I see people getting jackets on. Yeah. So, so there's really kind of like two types of data centers that I guess the industry kind of thinks about. One is the classic enterprise data center, and then the cloud or hyperscale data center. And these are where the different features would apply.
You would put computational storage in the cloud and not in the enterprise? I don't know.
Yeah.
No, I'm just saying. I thought it would also happen in the enterprise side.
Well, I think I guess I'd have to look more at some of the specifics, but I think when it was created with the cloud in mind. And a lot of the folks like, from Meta and Amazon and Microsoft are building these specifications and updates. But I certainly see what you're saying about computational storage. I would think of it as enterprise as well.
You don't really take it off your enterprise, does it?
Take it off anywhere, is it?
Not that I have seen, but it was really announced last year. So I would think that hopefully, if companies are actively developing it, then we would see something by now. But I'm not aware of anything specific. I mean, there's companies like Pliops that were focused on computational storage, but I think a lot of these companies are kind of pivoting a little bit. Then just a quick look at the feature roadmap. Like I said about SAS, that everything is going to be focused more or less on features as opposed to kind of large scale specification changes. Large scale, like the NVMe base specification, that will continue to evolve because that's the core of NVM Express. But a lot of these are features. Again, this is computational storage. This was, let's see. Yeah, so these are ratified. So yeah, as people are developing them, if they just got ratified under NVMe, then it's really, we probably won't see much until 2025.
Could you discuss the NVMe support for CXL, please? How would that work?
I actually have asked this question a bit too, because CXL basically sits on top of PCI Express. NVMe commands sit on top of PCI Express. But I think what CXL will allow is for these devices to, like CXL is meant to do, is allow them to talk at the byte level as opposed to the block level. I don't know the specifics of what has to happen to the NVMe command set to support byte level, because that's how CXL talks. DRAM talks at the byte level, and in order to make Flash work in a CXL environment or a DRAM environment, it would have to be able to talk at the byte level as opposed to just the block level.
Could NVMe simply adopt CXL?
Yes, it could, but I don't believe that will happen. It's certainly not anytime soon. But I think this is the first kind of discussions between the CXL group and NVM Express. I remember at least a year ago, at the previous OCP, actually it might have been 2 OCPs ago, where CXL was really just starting to get a foothold as a technology. And if you know Amber Huffman, she basically was the originator of NVM Express. I sat down with her and I asked her, why would anybody want to put an run the NVMe command set over CXL, and then which sits on top of PCIe, because you're just adding a layer. And back then, she wasn't aware of any real reason for that.
So just looking briefly at what some people have written, it appears coherence as part of the benefit. So it can be coherent with the CPU's memory space. So that's one aspect. Another is cuts down potentially a lot of actual data movement.
Yes. Thank you for checking. But to Chris's point, by putting the NVMe command set on top of CXL, you're adding a layer of translation and potential, latency.
Who cares? What does quality of service actually mean?
What's that?
What does quality of service actually mean? So I thought you must have had a quality of service ever since it started. So what's actually happening new in 2025?
Well, the quality, these are kind of, I want to call them, like quality of service, resiliency. I'm not exactly sure what post-quantum security is, but quality of service and resiliency are, a little generic, as opposed to a specific feature. But quality of service improvements, things like consistent latency and performance, are really important for hyperscale. Because if you have an SSD that goes into garbage collection mode, and then you get a tail latency, that slows down much more than just that one SSD. So it could be more along the lines of.
It's not quality of service. It's actually new quality of service features.
Yes. Yeah.
And post-quantum security, I'd have thought you would need that now, because if you're keeping data for 10 years, which is not unreasonable, in 10 years' time we might have quantum computers. So we need to have quantum safe encryption now, so that to allow for stuff to be kept up until when quantum computers come online.
I mean, that very well could be, being just kind of prepping for quantum computing.
Yeah. Then encryption is going to be possibly the less use of light encryption. It's going to go out of order.
Yeah, I mean, so some of this may be kind of an extension of, key per I/O, where a key per I/O is basically having an encryption key for every I/O transaction as opposed to doing something at a device level. So every I/O transaction will have its own security key, and that's what key per I/O is. So, the color coding, green, it's completed. Blue is what's coming up, and then kind of the orange, mustard color, is recently ratified technical proposals. Just a quick look, NVM Express in the enterprise. This is more or less the enterprise data center. I'm not really going to go into go through the actual slide, but why NVMe is a good choice for that, and then some of the recent features that will help support NVMe in the enterprise going forward. Cloud or hyperscale, there are a number of challenges that NVMe technology can make. Again, some of the benefits. And then, how many of you are familiar with flexible data placement? Good. Yeah. Yeah. So flexible data placement is technology that basically allows you to kind of specifically place data in a fashion that it becomes more sequentially written, and you can do the block erases as a full block as opposed to just a piece of it. With the intent is to get the right amplification factor to 1. So that what that does, it basically extends the life of the drive, and you can get better performance. And not to leave out AI. Why is NVM Express a good technology for AI? Because it's fast and low latency is probably the summary of it all. And then one other use case that looks familiar. So and the reason why I'm showing this is because NVMe SSDs go in the edge line. So in addition to SAS, NVMe SSDs are up in the ISS right now as well. Okay, from a sustainability standpoint, this is probably, in addition to things like flexible data placement, standardization, and reprovisioning, NVM Express, as the performance gets better, you can make the argument that you get more performance per watt of power, more performance per watt per dollar, or more performance per dollar. Basically, you can get better application performance and productivity, which should be a reduction, at least compared to the previous generation. It should be saving power and definitely saving cost.
What worries me a bit is how much of this stuff is used for drawing pictures of cats on the internet. How much of the performance is actually used for something useful, and how much of it's being wasted on.
Right, yeah. Well, hopefully there's enough productive use of the technology.
With a hype cycle for AI at the moment.
Yeah, we're definitely AI is in its prime of its hype. So we'll see if the use cases really show, or if Skynet is going to be born. Yeah. So in summary, NVMe technology continues to be adopted. It started as a simple PCIe NVMe SSD. Now it covers way much more, and certainly is focused on the data center. dedicated NVMe technical community. You saw that list of the promoters, and there's another 100 companies that are all members, and most of them are contributing. And then what's going to be coming, you'll see more news in 2025 around CXL, some of the QoS enhancements, the fabric resiliency, and post-quantum security. Okay. Any questions? I asked you guys questions, multiple choice questions, so you can ask me questions, but they have to be a multiple choice. So, if you want to stay in touch, NVM Express, you can certainly follow